Hello, fellow watchers, and welcome to our pilot episode of the Three Goobers. Today's topic is going to be about optics.
Fun thing you should say about that. That's how we actually met.
Oh yeah, I had actually brought my new invention to yoga class. The first reflecting telescope, and I was examining the light in the direction where Da Vinci was, and he realized, so he goes up to me and says,
The lights we may illuminate opaque bodies are of four kinds. There are diffuse lights, as that of the atmosphere, and direct as that of the sun. The third is reflected light, and there is a fourth which passes through translucent bodies, as linen or paper.
And I come up to the picture because I was eavesdropping and said, light is quantized in photons. And right there we found out we were the three best friends that anybody can have.
Anyways, let's answer our first question from our viewer. This one is from Nick, resident of the Dirty Bay, and he asked, what is Snell's law and index of refraction?
Oh great, he had to bring that guy up. Why are people so interested in Snell?
Well, laws are usually really important. For example, Newton.
Oh yes, I'm very famous for my laws, and Snell's gave the relationship between the angle of incidence and angle of refraction. Light passes from one medium to another, represented by this equation.
Now, index of refraction is the ratio of the speed of light in a vacuum to the speed of light in a medium under consideration.
Great, break time, give us 5.
Goody, I brought us some apples so we can get inspired.
Great, nothing with me.
Thanks, but no thanks. I'd rather go have a smoke. Okay, we're back with our next question, and it says, what is the difference between refraction and diffraction? Well, diffraction is the interference of light due to bending around objects, and refraction is the change in direction of light due to passing from one medium to another. Next!
Okay, next is define polarization and how it is used in real life. Well, polarization is a phenomenon in which waves of light or other radiation are restricted in the rate of vibration. For example, these cool shades.
What? More? Why are you asking all them questions?
You agreed to do this with us, so don't complain. Anyways, next on the list is what's the difference between a virtual image and a real image?
Real can be formed on the screen, and virtual can't. Duh.
Okay, where does an object have to be located to have a virtual image with a convex lens?
Right here. Nah, JK.
Virtual image is produced through a converging lens. When an object is placed below the focal point, it's upright and enlarged.
And through a convex lens, wherever it's placed, because it always produces an image with similar characteristics, upright, reduced in size, and located on the same side of the lens as the object.
To create a real image, an object needs to be located anywhere past the focal point, which will produce an inverted and reduced in size image, and there will be no real image produced by a concave lens.
Now Einstein is going to answer the next question.
Wait, first I need to get inspired. Where's my compass? Here it is. Okay, what's the question?
What objects have a focal length that's negative?
Negative focal lengths are imaginary and can never focus light on one point.
And last question of the day. What is a ray diagram and how do you draw one?
Let's get the artist to demonstrate. Leo, show them how it's done.
Okay, first draw a line parallel to principal axis, a line through focal point A, and a line through center of curvature C. And all of this lines are drawn from object to mirror. Then draw a line through focal point F and a line parallel to principal axis. And all of these are lines drawn from mirror to image after reflection, like this.
Oh, like this?
Or like this.
Yeah, I will draw a ray diagram later.
And don't forget the ray diagram traces the path that light takes in order for a person to view a point in the image of an object.
Well, that's all for today, folks. Don't forget to hit us up on our next episode of the Three Goobers.